Okay, so I have my next example. I have 4x plus y equals 13 and 8x plus 2y equals 26. Notice that this one's already set up properly. My x's and y's are both on the left-hand side. My constant is on the right-hand side. So I can go directly to choosing a variable to eliminate. Let's go with the x's this time. So we're going to do our x's here. We've got an LCM. Again, I want to find a number that I can build both 8 and 4 up to, and that number is actually, the smallest number is actually 8. However, if you said 16 or 32 or anything larger than that, it would work just fine. Remember, as long as we can build up to the number, it'll work. We want to try to do the smallest one just because that way we have smaller numbers, but we can go bigger if we don't see that smallest one at first. Now, I also want you to notice that look at this second equation. Look at his coefficient. He's already a positive 8, so I don't actually need to do anything to that second equation. I'm going to leave him 8x plus 2y equal to 26. However, the first equation is a 4x, and he's positive 4x, so I need him, because he's a positive 8, I need this guy to be a negative 8. So we're going to multiply this top equation by a negative 2. Multiplying by negative 2 is going to give me that opposite sign. So I'm going to end up with negative 8x minus 2y equals negative 26. And then I'm going to take these two equations and add them together. Now something funky is trying to happen in here. Look at this. Notice that my 8x's cancel each other out like was planned, because that's what I was trying to do, eliminate those x's. But my y's also eliminate each other. So if my x's and my y's are both eliminated, the only thing left on the left-hand side is 0. Equal to, well, negative 26 minus 26, that's also 0. So then my question is, well, what's my answer? It's obviously not one solution because I eliminated both my x's and y's, so I don't have any x's or any y's to say that x is equal to or y is equal to. So now my choices are between infinite number of solutions or no solution. So remember the difference. Infinite number of solutions is when that is the same line, so every single point has something in common. And no solution would be where they're parallel. Well, think about this. Does 0 equal 0? Yeah. So that probably means that these are actually the exact same line, because that means that no matter what value I pick for x, it's going to work. So anytime I get what we call a true statement, this is true for both the substitution or the elimination method. Anytime I get a true statement, that is automatically an infinite number of solutions. Okay, again, if everything cancels out, my x's, my y's, and my constants all cancel, I get that true statement that 0 equals 0. I have an infinite number of solutions. Okay, so this is our last problem we're going to look at. Again, wanting to first look up and make sure that it is in proper format. Both my x's and y's are over on the left-hand side. My constants are over on the right. Everything's lined up nice and pretty. Again, I want to eliminate a set of variables. Let's go with our y's this time. Our LCM. Now remember, when you don't have a number in front of your y's, the LCM is, or the number is 1. So the LCM between 1 and 1 is 1. So that just means that I need to make one of, since they're both positive, I need to make one negative, I need to keep one positive. So what I can do is I can just take this first equation and I'm going to multiply him by negative 1. That's going to change my y to a negative, and that's going to make my y's opposite of each other. So I'm going to have negative 4x minus y equals 11. And then I'm going to leave my bottom equation alone, so that's going to give us 4x plus y equals 29. Again, adding the two equations together. Now, just like our previous example, both my x's and my y's cancel, so that's going to leave me 0. But unlike the previous example, 29 and 11 don't cancel out. That's actually going to give me 40. Now the question is that a true statement? And 0 definitely does not equal 40. Therefore, my answer here would be no solution. Okay, these are parallel lines. They don't have anything in common. So again, when you have a true statement, something like 0 equal to 0, that's an infinite number of solutions. When you have a false statement or a non-true statement like 0 equal to 40, that's a no solution. If you come out with x equal to a number or y equal to a number, then that's one solution. You have to plug that back in, find the corresponding value.